In this video we're going to discuss Euler's number and we're going to look at exponential equations involving base e. So, introduction now to Euler's number. Euler's number is involved in problems involving natural growth and decay. Okay, often graphs like this or like this. Okay, where quantities are increasing over time, rapidly or decreasing over time. So they're the sort of problems we're looking at. We'll get to some more practical things with Euler's numbers later on. But Euler's number is like pi. Okay, it's a non-recurring decimal. It goes on and on and on and on. Okay, so it doesn't stop there. And it's roughly 2.718 to 3 decimal places. As I said, it's an irrational number. Rational means it's a non-recurring decimal. When we give an answer in terms of e, for example, I give an answer, say 3e or e on 2, we call that an exact answer. Okay, sometimes we're asked that in exams, give the exact answer for this, and it's in terms of e. Right, the E laws, for want of a better word, okay, E laws, are similar to the index laws. And you can see that. E to the power of x times e to the power of y is e to the power of x plus y. So in other words, e squared multiplied by e to the power of 3 equals e to the power of 5. Just pointing out at this stage that e is not a variable. It's not like x or y or z or a or b. It's an actual number. It's like pi. E to the power of x divided by e to the power of y is e to the power of x minus y. I'll just get that phone call. Okay, so if you had e to the power of 5 divided by e to the power of 3, that would be e squared. Same sort of rule as before there. E to the power of x to the power of y. So if you had e squared raised to the power of 3, that would be e to the power of 6. E to the power of 0 is 1, and we know that anything to the power of 0 is 1. So that's a pretty obvious one. And e to the power of negative x, okay, it's 1 over e to the power of x. Another one here, last one here, and look at is e to the power of x over y equals the y-th root of e to the power of x. So if we had e to the power of 2/3, that would be the cube root of e squared. Okay, so there's a bit of a rundown there on the laws dealing with e. E can also be the base in a log expression. So for example, we can have log 3 to the base e. Now, log base e expressions, okay, can also be written as ln x, sometimes called ln x. Okay, so they are equivalent. I'll just write them out again so it's very clear. Log x to the base e, ln x. I tend to do the left-hand one. So when you see me do problems, I rarely use that terminology, although it does come up in questions and in our books on occasions. Right, let's look at some equations here. Solve for x. E to the power of 3x equals e. Alright. First thing to realise here is that we can make this e to the power of 3x. E by itself, as is anything by itself like that, is e to the power of 1. Now in these equations, once we've got e on both sides, got e there, and we've got e there, okay, we can drop the e's out, okay, and that means we just get 3x equals 1. So we're making those two equivalent to each other. Therefore, x equals 1 on 3. Another equation, e to the power of 2x minus 1 equals the square root of e cubed. So we can make that e to the power of 2x minus 1 equals e to the power of 3 raised to the power of a half. Remember, square root and the power of a half are the same thing. If I remove those brackets now, e to the power of 2x minus 1 equals e to the power of 3 on 2. Pointing out, as in the last problem, now I've got e there, and I've got e there, so I can now drop the e's out. and I've got 2x minus 1 equals 3 on 2. Multiplied through by the 2, I get 4x, take 2 equals 3. 4x equals 5 by taking that negative 2 across. Therefore, x equals 5 on 4. 3 to the power of, 3 times e to the power of x equals 4. Alright, what are we going to do here? Well, the first thing I would be doing here is dividing through by the 3. For e to the power of x equals 4. Now, how do we get this x here? How do we get that x there by itself? When our unknown is an index, I might write this out actually. When unknown, for example, x is an index, use logs. Okay, so when unknown x is an index, use logs. So all I'm going to do here now is change this into log form. And we know how to do that, okay, because we go put the log down, e to the power of x on the right hand side equals 4. Remember I talked about that clockwise direction thing? Okay, e to the power of x equals 4. So, that's it. Oops, wrong colour pen. Go back to the red. Therefore, x equals log 4 to the base e. Now, that can be worked out on your calculator if you wish. You'll see we can work that out on the calculator. Log 4 to the base e equals x. Or we can just leave it as it is. By the way, if you're working on the calculator, you're looking for ln4 there. That's one of the calculator functions. Okay, next question. 3e to the negative x minus 2 times 2e to the power of x minus 1 equals 0. Now what we're going to do is separate this into two separate questions effectively. So we've got 3e to the negative x minus 2 equals 0. And we've also got 2e to the power of x minus 1 equals 0. So two separate situations there. Make that 0 a bit better. Let's work, and I'll put a line in between them so we can clearly see the difference. Let's work on the left hand side one first. So this would be 3e to the power of negative x equals 2, which means that divide through by 3, e to the power of negative x equals 2 on 3. Now remember what I said, if your unknown is in the index, convert it to log form. So log e to the power of negative x equals 2/3. Okay, now if I get x by itself, I divide through by negative 1, which means that negative log 2/3 to the base e, might pay there to bracket the 2/3, equals x. So what I've done in that last step is just divide through by negative 1. Let's go to the other side. 2e to the power of x equals 1. E to the power of x equals 1/2. How do we get x by itself now? We changed it in a log form. Write down log e to the power of x on the right hand side equals 1/2. Okay, so we've got our two answers. That one there, and also that one there. I mentioned before we can work these out on the calculator if you wish. Now, of course, we could solve the whole thing on the calculator. I didn't mention that, but it's worth knowing how to find something like negative log 2 on 3 to the base e. Remember that log base e and ln are the same thing, so it's negative ln 2 on 3. So on your calculator, ln is found at control e to the power of x, and then if you put 2/3 in brackets and press control enter, you get the answer there of 0.405. For the other one, log a half to the base e. Okay, so once again you go on your calculator, control e to the x, which is ln, and 1 over 2, and the answer there would be negative 0.693 to 3 decimal places. Let's take the last question one step further, and we've got a question such as this. First thing I'm going to do is change the order of things here. 3e to the power of 2x minus 11e to the power of x plus 6 equals 0. Now, does that vaguely look like a quadratic? Okay, so we've got x squared plus 3x plus 2 equals 0. That quadratic form, a squared term, an x term and a number. Alright, now we've sort of got some situation that resembles that. So let's look into this a bit further, and the first step here is crucial. What I'm going to do is I'm going to change the e to the power of 2x to e to the power of x squared. Once again, I think we've covered this in a previous video. These three things are the same. E to the power of 2x, e to the power of x squared, and also e squared to the power of x. Those three things are all the same. So please recognise those as all being equivalent. So back to the question. So it's minus 11e to the power of x plus 6 equals 0. That's starting to look quadratic. A squared term, a middle term, and a number by itself. So what I'm going to do here to get that into the form that I really want, I'm going to let e to the power of x equal a. So I'm going to make a substitution. So I can now say this is 3a squared minus 11a plus 6 equals 0. And now I need to factorise this. Okay, now we need to factorise 3a squared plus minus 11a plus 6. So I, as you know, use the grid method. So I've got the coefficients, the factors of 3a squared over here, 3a and a. And over here I've got the factors of positive 6. Why are they both negative? Because the middle term there is negative. Okay, so that's why I've got negative 2 and negative 3. And I've got a positive 6. So whenever I have a positive number and a negative middle term, I need negative, negative. Now if I do the cross method here, okay, 3a times neg 3 is neg 9a. Neg 2 times a is neg 2a. Total of negative 11a. And that's handy because that's the middle term. So in other words, if I factorise this, I get 3a minus 2 and a minus 3 equals 0. Once I get to here, I've got my two separate scenarios. 3a minus 2 equals 0 and a minus 3 equals 0. And then I can do those separately. Now I can substitute back in because I know that a equals e to the power of x. So I substitute back the other way. Equals 0. And, e to the x minus 3 equals 0. So on the previous slide I substituted, remember, e to the x equals a. Now I've factorised it, I go back the other way. So we have 3e to the power of x equals 2. E to the power of x equals 2/3. Convert to log form. Remember how we do that. Write down log. E to the power of x equals 2/3. Okay, so there's my answer. Log 2/3 to the base e. Other answer. E to the power of x equals 3. Log form. Log. And e to the power of x equals 3. Okay, and there's my other answer. And they could then be calculated on the calculator, in the calculator section, or if it's a non-calculator section, you just leave the answers as is. Okay, the hardest questions in this section, these type here, e to the power of x minus 3, e to the power of negative x equals 2. Yeah, sort of vaguely like a quadratic, but much different, or not as close to being a quadratic as the last one was. But it's going to be a quadratic equation eventually. So what we're going to do, first up, if you recognise these, they're not too difficult, but if you don't get this first step, or first couple of steps, you're in a lot of trouble. So the first thing I'm going to do is take the 2 to the left hand side and put a 0 on the right. So I've just switched this guy over. Okay, now how do I make this into a quadratic? I'm going to multiply everything here, here and here. I'm going to multiply by e to the power of x right through each bit, multiplying by e to the power of x. Okay, so watch this. If I multiply that by e to the power of x, I get e to the power of x squared. Now what happens if I multiply 3e to the negative x by e to the power of x? Alright, well I get 3, and I've got e to the power of x, negative x times e to the power of x. I add the indices, negative x plus x is 0. So I actually get, 3e to the power of 0. E to the power of 0 is 1, that gives me 3. So my next term is negative 3. And then the last one I multiplied by e to the power of x, and I get negative 2e to the power of x equals 0. So it looks less cluttered. I'll now rub out this little connection here. But what I've done is multiply everything. Multiply each term by e to the power of x. Right, and that gets me the line I'm on now. That looks more quadratic-like. And now I can make my substitution. Let a equal e to the power of x. Next line now. A squared minus 3 minus 2a equals 0. Let's order that properly. So it's a squared minus 2a take 3 equals 0. Alright, now we need to factorise this. So we get a minus 3, a plus 1 equals 0. So therefore we get a equals 3, or a equals negative 1. Alright, so it's time now to substitute back in for a. So that means that e to the power of x equals 3, or e to the power of x equals negative 1. So if we look here, convert these now to log form. Log base e to the power of x equals 3. Log base e to the power of x equals neg 1. Let's tidy that up a bit. Now when we get a situation like this, get a negative 1 there, that gives us no real solution. So remember that a negative value, where that negative 1 is, gives us no real solution. This one, no, is okay, and we can leave it at that, or if we had a calculator, okay, to be ln3, which would be to 3 decimal places 1.099. Should be able to now do exercise 3E, numbers 2 to 7, and that's on page 146. Okay, that's all for now.